It's always so lovely to host you here every Wednesday of the month. Greetings, fellow leaders from the African continent and across the world. Welcome to yet another live session brought to you directly from Digital Earth Africa. My name is Maud Nale. I'm the communications lead here at Digital Earth Africa. And today we're going to be talking about desertification. If this is the first time you're hearing about it, don't worry. Our facilitator or our presenter today is going to tell us all about this and how Digital Earth Africa fits into this picture. She is from one of our implementing partners. They are based in Nigeria, and they are called the African Regional Institute for Geospatial Information Science and Technology, or in short, popularly known as AFRIGIST, based in a university based in Nigeria, and she is a lecturer in the Department of Geospatial Information Science. Please join me in welcoming onto the virtual stage our facilitator today, Dr. Ozien Phoebe Mamudu, who will be talking about desertification. Doctor, if you could turn on your video, unmute yourself, the virtual stage is yours. Over to you.
Oh, hi, everyone. Good afternoon from this side. Good morning, good evening, depending on where you're joining us from. I'm going to turn off my video just because of the internet bandwidth. I'm going to be talking about desertification. Desertification, basically, we know is a phenomenon of drier regions of the world whereby vegetation dries up. We have decrease in vegetation, loss of water and all other features that relate to dryness, right? And so it becomes important to study this because we see that it's affecting livelihoods and people in various parts of the world, especially in the drier regions of Africa. Now, this notebook is bringing together three major indicators of desertification. So in this notebook, we're looking at soil moisture, fractional cover, and vegetation change as they indicate towards desertification. So basically, we're looking at these to see how they play together to be able to enable us to analyze the phenomenon that is desertification. So if you go through the notebook, these three notebooks, the soil moisture, fractional cover, and vegetation change detection, are available on the sandbox under the real world examples folder. So anyone can access them, but we'll also make available this combined notebook for anyone who would like to go through it at their own time later on. So, like I said, we're going to analyze soil moisture, which is basically root zone moisture and soil moisture as indicators of desertification. We're also going to be looking at fractional cover, which basically estimates the proportion of green vegetation, non-green vegetation, and dry vegetation in an area. And then we would also now look at change detection to be able to see how much change would have occurred in our study area over the period of this analysis. And based on that, we'll be able to see whether there seems to be any indication of desertification in the area. So to get started, we go ahead and load in our packages as shown here. And then we connect to the data cube. And then we determine our location. For this study, the location is the Funugo village in Banikoran, Banikoran in the northern part of Benin Republic. And the coordinates of the location are given as shown right there. So these are the output CRS, the resolution of the imageries. The time period for which this study was carried out was 2015 to 2020. Now, even though we know this is a short period for analyzing desertification, it was the time period for which we were able to get most of our data sets, particularly the soil moisture data sets. So it gives an indication of what we can do with this kind of data sets using the DE Africa platform. And of course, it means that in future, we can maybe in the next 5 years, we can run similar analysis to be able to see what could have changed in a longer period of time, as the case may be. All right, so here is a display of our area of study. Like we can see, it's a northern region, and some of the characteristics of this area is low vegetation. The amount of vegetation in this area is generally low, but it's also an area that is largely farmed. So there is a lot of agricultural activities also going on in that area. So the first thing we do is to track the soil moisture and precipitation over time. So to do that, we are going to load both the surface wetness data and the root zone soil water index, and use that to see what the changes in soil moisture may have been in the area over the period of study, 2015 to 2020. So we load the soil moisture data, which is based on the graphs data sets. It's available online, but you can always get through it using this these codes on the Digital Ed Africa notebook. So we load that based on this parameter. We are able to load the surface wetness for the study area from 2015 to 2020. Similarly, we're able to load the root zone wetness index data from same graph from 2015 to 2020. Now, this loaded is just the links to the data set. However, for us to be able to visualize it, it becomes important for us to plot both the surface and the root zone wetness. And so the following codes allow us to plot the surface and root zone wetness. And given here is the plot of the surface wetness and root zone wetness for the Funugo area between 2015 and 2020. And of course, we can analyze this to see in which periods did we have the least soil moisture and root zone wetness. And we can see that fell in the period between 2019 and 2020. Right? And so we can use this to give an indication of when we may have had most effects of dryness in that study area. Now, the next data set we are loading is the precipitation data from the ERA5. And so we'll load that precipitation data using the codes in this cell. And we'll go ahead to plot that precipitation data in line with the soil moisture and root zone moisture data. And here is the plot. Now, we can see that the precipitation, which is given by the brown colored line, we can see that precipitation, though was lowest in between 2017 and 2018, did not too much affect the root zone and soil moisture in that period. But 2020, that had the least soil moisture and root zone, also had a minimal amount of rainfall. So this also gives us an indication of how much precipitation we got in these periods and when we had the least amount of soil moisture and root zone moisture, giving us an indication of higher dryness and probably some indication of lower yield, as the case may be. So that's the soil moisture data set. Next, we try to analyze vegetation cover in the study area over time. And we are doing that based on the fractional cover. Like I mentioned earlier, fractional cover looks at the proportion of green vegetation, non-green vegetation, and bare soil in the study area. And so we use the parameters that we had specified in the beginning to generate a query, the parameters being the time range, which is 2015 to 2020, the latitude and longitude, as well as other parameters here. And so we created that query, and then we used that to load the fractional cover data, the Landsat fractional cover data. Now, that being loaded, we had about 227 imageries, but because of cloud and other disturbances, it becomes important that we mask out or remove some data that are not too good for the study. And so we carry out a cloud and water masking based on the water observation from space data sets. And so after carrying out that cloud masking, this is some of the data sets we're able to get out of it. We now reduce the minimum, we select the data set available based on a 0.95 minimum good data. And by the time we run that, we only worked with about 50 images from the 227 that we got earlier. Now, based on these images, we're now able to run the fractional cover. Now, the legend of the fractional cover is given here, such that we have three extremes: the green vegetation, the non-green vegetation, and bare soil. And so we have a mixture of other values given here, such as the green mix, the non-green mix, the non-green and green, the non-green mix, non-green and bare soil, bare mix, bare and green. And so we run the fractional cover for the images we got between 2015 and 2020. And here is the result of our fractional cover. So that we can see that from this period, which is about January 2015 to about July 2015, we are seeing more of non-green vegetation. If we consider that most of it is between blue and red. So we are seeing mostly non-green vegetation. However, we can see that in August or September 2015, in October 2015, we are beginning to see more of the greener vegetation. This also gives an indication of the weather, the seasonal periods in this study area. Around here, we can say it's mostly dry season, and then by the July, we are beginning to have more rains and more greens, and the area becomes green until it becomes dry again. So we're able to analyze the monthly fractional cover in the study area between 2015 and 2020. Now, having done that, the next we tried to do was to calculate the average fractional cover over time and then plot the fractional cover into a graph so that it allows us to see the extent of photosynthetic vegetation, which is the green vegetation, non-photosynthetic vegetation, which is the non-green, and the bare soil. And then we can clearly see that at the periods when we have the highest photosynthetic vegetation, which is the green vegetation, are when we have the lowest amounts of non-green vegetation as well as bare soil. And that translated into most years in our time study. However, we can see sometime in 2020, we seem to have a lot of non-photosynthetic vegetation and lower amounts of green vegetation, that's PV. Now, this also still tallies with what we saw when we looked at the soil moisture, where we saw that soil moisture seemed to have been at its lowest around 2020. And so we can almost see that that period too also had a high amount of dry vegetation. Now, looking at vegetation change detection, which is the third aspect of our indicators for desertification, we load in the Landsat image given here, where we have 129 images timestamp. And so we just plotted out two of those timestamp, which is one in 2015, given here, and one in 2017, given here, of this exact same area. Now, to analyze this, we use the NDVI. NDVI is one of the indices that allows us to analyze the greenness of vegetation. And so we made use of the NDVI to calculate the amount of green vegetation in that study area over our period of study, and plotted it in a graph here, which is given thus. Now, we also visualize the NDVI for our time period 2015 and our mid-time period 2017, as shown here. Now, being as this is just visual, it's going to be difficult for us to see if there is any real changes in the area just by looking at the NDVI of 2015 and that of 2017. So we chose to create a hypothesis. The hypothesis basically says that it wants to be able to test whether there is any significant change in the study area. So while it's possible to visually detect changes between the two time steps, it's important for us to check for both changes in vegetation, whether there's any evidence of afforestation, or negative change, which is evidence of deforestation. And so to do that, we divided our data sets into a baseline data set and post-baseline data sets. So we have our study between 2015 to 2020. So we chose our period between 2015 to 2017 as a baseline, and post-baseline to be 2017 to 2020. And so based on that, we selected samples from each of the periods, the baseline period and the post-baseline period. And so we had 58 samples in the baseline period and 71 samples in post-baseline period. Basically just points in those periods where we are going to compare if there have been any changes. Now, analyzing, testing for change using the t-test, we are able to determine some negative changes in the study area. And using a significance level of 0.01, we are finding that there is some minimal statistical change in the study area. So our result here is showing us the baseline composite of our image, the post-baseline composite. And then here we can see dots showing where there was any significant change in the study area. And here showing us dots where we can see where there was significant statistical deforestation in the study area. Now, the difference being that some of the changes that are here may not necessarily have been deforestation, could be maybe just change from one land use to the other. However, this specifically indicates significant deforestation in the study area. And so to take it from just visual to being able to analyze percentage change, we calculated the percentage change in both the baseline and the significant difference. And we are finding that 0.08 of the pixel underwent significant change in any direction, while 0.03% of the pixel likely underwent deforestation. So we have some deforestation in the study area, giving us only 0.03% of the pixels. And to just further go into bringing these notebooks together, we try to compare soil moisture, the precipitation, and the fractional cover together using these quotes. And here became our results, where we're able to see the surface wetness given as blue, the photosynthetic vegetation, green vegetation given as green, and the precipitation given as brown. And we can look at this together to be able to see how much each of these factors worked together and in which periods we had the driest years, which gives us some indication of desertification. Now, while this study was conducted only between 2015 and 2020, there is only so much change that we will be able to see in such a short period of time. However, like I said in the beginning, we are able to see the possibilities that are available using all these data sets. And we can look at it again in another few years to see how much change would have occurred, say in maybe 10 years, for example. And as time goes on, be able to gradually monitor to see whether precipitation is reducing, whether soil moisture is changing, whether deforestation itself is actually occurring. So that brings us to the end of this notebook. I want to especially thank my team in AFRIGIST, Mr. Yajemi, Mr. Suma, Mr. Adimu, Mr. Luko, Dr. Labamiji, who will work together to making this notebook, possible. And special thanks goes to Victoria Inyaga and Edward Wama, who also helped us in troubleshooting any problems we had when we're trying to come up with this notebook. I want to also encourage us to go through the e-learning platform. Some of these are already available there, so we can always go through them, change the study area, play around with it, and see what changes may have occurred in areas that are more familiar, in areas we are more familiar with. Thank you very much, Maud. I think I can hand over to you now.
No, it's thank you to you, Phoebe, Dr. Phoebe, for that presentation. I'm not from a science background, but this made so much sense to me. And I know that the participants, it definitely makes sense to them. In fact, I'm seeing some comments in the chat box saying that this was such amazing research that you've done and wondering if this notebook is available and where can we find it? Where can we find this notebook, Doctor?
Okay. So this particular one could be shared maybe in future, maybe at the end of this training. However, like I mentioned, if you look at my table of contents here, you see soil moisture, fractional cover, and vegetation change. Those are available on the real world examples folder on the sandbox right there. But we made some slight adjustments to this one that we call desertification. So it can be made available right after this training for anyone who wants to have access. But like I also said, it's already available on the e-learning platform. We've already tried to make this the trainings available there, where you have land degradation. So it's under the course land degradation. So anyone can feel free to go through it and go through the notebooks right there.
Thank you so much for that clarity. So if you go on to learn.digitalearthafrica.org, we've got our online courses there in English and in French. And this particular course, which is part of land degradation, it's going to be starting this coming Friday, the 19th of May, the English one. And then a week later, which I believe is the 26th of May, the same course will be in French. So don't worry, we have you covered no matter whether you speak English or French. So please log on to learn.digitalearthafrica.org if this is a particular course of interest to you and you want to take your learning even further. Dr. Phoebe, thank you so much for that presentation. I'm seeing some questions coming through from the chat box. We will give leaders an opportunity to ask questions, but there is one in the chat box that says, is there a way that you can use the notebook to make prediction of likely changes?
Okay, well, at the moment, I'm not sure, because what we have analyzed is what is not necessarily what could be, but I think it's something we can look into for the future to see if we can predict changes. But for now, we didn't go that far. So I hope that answers him. We didn't go towards looking towards prediction just yet, but I believe it's something we can look into and see the possibilities of.
Thank you so much. And if that does change, we'll certainly communicate on our various platforms. I'd love to give others an opportunity in case someone has a question or a comment. Dr. Phoebe, at this point, you're more than welcome to stop sharing so that we can see everyone in full view. If there's anyone who has questions or comments for Dr. Phoebe at this point, we're quite a large group today. It's lovely to see so many leaders from across the continent. Any questions or comments? I also noticed that there was another fellow colleague who was also a youth mapper from Zimbabwe. It's lovely to have everyone who's here from across the continent. We never want to leave these sessions without giving you an opportunity to connect with us. So at this point, I'm going to share on the screen all the ways that you can do so. You can connect with us via our website, www.digitalearthafrica.org. We're also on email, info@digitalearthafrica.org. I also want to speak about the learning platform that Dr. Phoebe spoke about earlier. If you're wanting to do any course in English or French, hop on to learn www.digitalearthafrica.org, and you can take on enroll, and you can take on any of the courses. And a reminder that the course on land degradation is going to start this coming Friday, the 19th of May. It's going to be in English, and then the same course in French is going to be the following week, Friday, again on the platform. And then, of course, we're also on social media, very active in that space, Twitter, LinkedIn, as well as YouTube. You can find us there by the very same name of Digital Earth Africa. We host these sessions every week, English and French. So I hope you found today useful. If you prefer a session in English, we're going to have it next week, so don't worry, we have you covered in that. It's been a habit or a ritual here at Digital Earth Africa that we take a group picture with a live session, which is going to be desertification, but it's going to be in French. So if you prefer it in French, please do join us then. And reminder that this community is for everyone. So if you're wanting to do your research, you're professional anywhere, as long as you're on the continent, we definitely will be able to assist you. And who knows, you might be able to find your next professor, your next funder, your next whoever in this group. So please do join us again next week. It's been amazing hosting you. We'll meet again next week.